We've got one from Tyler that's a little bit more on the technical side. Maybe we'll start with that. For PICs, packaged integrated circuits, waveguides, and fiber arrays, how big of a bottleneck is post-dicing facet preparation before packaging and optical coupling?
Yeah, thanks, Tyler. That actually is a general challenge. And the problem is that usually happens pretty much back end, right? So you've done through all the steps and all the processes, and once you're done at the product's almost there, you're doing this. So this is so the short answer is it is a it's certainly a very sensitive step. Let's put it this way. Yeah. Um, so indeed, the way I would frame it is like really for many PIC platforms, the object interface at the chip edge is really one of the sort of least scalable, but also most sensitive steps
Mm,
of the entire like manufacturing flow. So I think you hit an interesting point here.
yeah.
Um, um, And I mean, interfaces, of course, we know why they're important, right? Because they like insertion losses and reflections, and they like directly lead to link budget quality and link budget, think bit error rate, right? Energy per bit, and so on. In fact, the whole metric from a link perspective is it's a mouthful, but here it goes. It's basically, let's say a giga or terabits per second for per shoreline millimeter per picojoule per bit, right? So it's more data per unit shoreline. That's where your edge dicing becomes critical or becomes an relevant part, and the packaging connector piece selected and chosen. And there are many developments right now, right? Terramount, pluggable ones, and so on. Global Foundries pushes quite a lot of this as well. Some interesting developments there as well, and others. Um, yeah, so like the shoreline per millimeter, and then obviously picojoule per bit, like relates to, of course, modulation speed, modulation format, and so on and so forth. And then, yeah. Um,
So if you can help solve this problem, you're gonna help with a big breakthrough in the field, it sounds like, right?
yeah, at least it's to be honest, this by itself would not be entirely solve an entire section, but
Right.
it is unfortunately it's just one of many
Many.
that
Yeah.
needs to
Yeah.
be addressed.
Yeah.
It's an all of the above, right? So
Right. Yeah.
to get it right.
Yeah.
But yeah, I mean, like, if you break it down, this problem, dicing, obviously, damage, cycle roughness, all this micro cracks, roughness, contamination comes to mind. All of these things we need to address
Mhm.
to get a proper edge. And for optics, it could be catastrophic for if not done right.